So, I'm again with you with another interesting topic. Let's start this topic without wasting time. So, today we will talk about visible light. In visible light, there are seven lights. The simple way to learn those light is one word, Roji. What's the word? Roji. From R, red, from O, orange, and from Y, yellow, from G, green, and from B, it would be blue, and from I, it would be indigo, and from Y, it would be violet. These are the seven lights in visible light: red, orange, yellow, green, blue, indigo, and violet. How to see these seven lights? Take a prism in triangle shape. Take a prism and incident the visible light or the sunlight on this. It's the sunlight. You will see the seven colors on the other side. Red would be on the top, red, then it would be orange, then it would be yellow, and in sequence like I have written here, it would continue till violet. There are seven colors in visible light. These are the seven colors. How their frequency and their wavelength changes. Like in electromagnetic spectrum, as we go from radio to gamma, the wavelength decreases. Same is the case here. As we go from red to violet, the wavelength decreases. And as we learned yesterday or in the last video that as the wavelength decreases, the frequency increases because they both are in. Now we'll talk about reflection and refraction. Before we'll talk about refraction and reflection, we'll talk about luminous object and non-luminous object. Luminous object and non-luminous objects. Luminous objects are those through which light can pass, and non-luminous are those through which light cannot pass. Luminous objects through which light can pass, and non-luminous through which light can pass. These are luminous and non-luminous objects. We can have examples of luminous objects like glass, and non-luminous objects any board painted with black color. Those are non-luminous through which light cannot pass. Now we will talk about reflection. Now we will talk about reflection. In simple words, you can say bouncing back of any object or any light is called reflection. And having same incident angle and same reflecting angles. For example, we have this surface. For this reflection, we always take non-luminous objects. In reflection, you can suppose that this is one ray incident on the surface. You can take this surface, and this is the incident ray. First of all, you have to draw the normal. What is normal? Normal is the line which is 90 degree to surface. 90 degree to surface. You can take protractor to measure 90 degree. I do not have protractor, so you will just draw a line. This is normal. We can write here what is normal. Normal. 90 degree to the surface. 90 degree to the surface is normal. How to make, we have drawn incident ray, how to make reflecting ray. For reflecting ray, you will take protractor and put here to measure this angle. This is I, which means incident angle. To make reflecting angle, you will have same angle to the normal as it is of incident ray. Mean to say, you will take as much this angle, you will take here and draw an reflecting ray. This is reflection. This is reflection. This is reflecting ray. Or you can say that it's suppose, and this is called reflection. This is reflection. We'll talk about regular reflection and non-regular, irregular reflection. First of all, regular reflection and non or irregular reflection. Regular reflection is on the surface which is smooth. You can say which is polished. For example, you can take this surface which is polished. Surface which is polished means which is plain, which do not have any bouncing or extra, which is plain. It's when it would anyway would strike this surface, there would be an regular reflection. But if the surface is irregular, you can suppose this, then the reflection won't be regular, it would be irregular. For example, if the rays strike here, and you can suppose if it strike here, it has two surfaces now. See, for this it have this one surface, so its normal would be as 90 degree to the surface, this. But for this, it has this one, then the normal would be this. As you can see that for a single plane, there are two normals. This means this is irregular surface. So here irregular refraction would occur. Now we will talk about the characteristics of the image formed by reflection in mirrors. Characteristics of image formed by mirror. The first character is that if this is a mirror and if this is an object mirror, the image formed would be equal distance from as the object from the mirror. For example, this is mirror and this object. If suppose that you would measure this distance is about 12.7, you would go here and put 12.7, and this would be our image. Mean first characteristic is that image form is equal distance from mirror as object from the mirror. What is first characteristic? Image form has same distance as object from mirror. This is the first character, number one. And second is that image form is upright, means if I'm standing, my legs are down and my head are up. If I've seen mirror, in mirror same would happen, mean my leg would be down and my head would be up, mean it's upright. Number two, upright. And number three is that the object that is formed, that is inverted. What is inverted? Mean to say, if this suppose I am here standing, my right hand is here and my left hand is here, but when I will see in mirror, my right hand would be here and my left hand would be here. Mean to say, it's inverted, it's invert. As you can see in ambulances, ambulance that is written at front of the ambulance is inverted, so that the man who is driving, he can see easily that in mirror that it's written ambulance. For example, if this is ambulance, the inverted words are written here, so that the man going in the car can see in mirror the correct word ambulance. That's why in front of ambulance, inverted words are written. Now we will talk about refraction. Reflection occurs when the mediums change. Now we'll talk about refraction. Refraction occurs when the medium changes. For example, from air particles, the light enters through a glass. With always this means to say refraction occurs in luminous object. Luminous objects. It also occurs in non-luminous when there is total internal reflection, but mostly it occurs in luminous objects, and it occurs when the medium changes. When the medium changes, the ray passes that way, mean it's changed its way, and when it change its way, when it go from lighter medium to denser medium, mean when it go from air to glass, it would diverge or it would refract towards the normal. For example, this is the ray and this is the normal, this is the surface. It would go towards the normal, but when the ray is passing from the denser medium to less dense medium, the ray would go away from the normal. For example, this is the surface. If this is the normal, it would go away from the normal. But in lighter medium to denser medium, it would go towards the normal. I will talk how to find reflective index. Refractive index. We can take two mediums. This is air and this is glass. Let's suppose a ray is coming, incident here, and it reflects like this, and the normal is this. The question is that find the reflective index, refractive index of air. To find the refractive index of air, you will see in this other medium and see this would be its incident angle. The formula to find the reflective index is sine I over sine R. So sine I, let's suppose this is 20 degree, and sine R you will take this one angle. Suppose it is 40 degree. You will solve this and reflective index would come. This would be reflective index of air. To find reflective index of glass, you use this one angle as I and this one as R. So now sine I over sine R would be equal to sine 40 degree over sine 20 degree. Mean to say, now this would be sine, this would be I, incident angle I, this would be, and reflective angle would, this one would be reflective angle, to find the reflective index of glass. Now we will talk about total internal reflection. Total internal reflection. What happens in total internal reflections? When the medium changes, for example, this is the surface line, this is the normal, and it's air and it's glass. When the medium changes and it strikes, the incident ray strikes on the surface, it has angle greater than or equal, greater than critical angle. What is critical angle? Critical angle is when the reflection, the reflecting or reflection ray has 90 degree to the normal. When this is the 90 degree to the normal, then this angle is critical angle. And when angle is greater than critical angle, the total internal reflection will take place. Mean to say, reflection would occur in luminous object. In luminous objects, reflection would take place. And now we'll talk about the uses of total internal reflection in optic fiber. Basic use of total internal reflection is in optic fiber. In optic fiber, you can take a fiber or a plastic to make a wire. In this, and a ray is incident on the surface. This is 90 degree, and this angle is greater than critical angle. So total internal reflection would take place, and this would go here. Here there would be also greater than critical angle, so this would continue like this, this, and this. The man on this other hand of the wire could see or project this image and receive the message. Now we would have short summary what we have learned today. Short summary. Firstly, we have learned about sound lights, invisible lights. The word that we learned today is rose biv. From R, red, O, orange, yellow, green, blue, violet, ignito, and violet. And then we learned about reflection. In reflection, we learned that the angle of incident and angle of reflection are equal. Mean they are equal, and we have also learned that normal is that which is 90 degree to the surface. Then we learned about reflection. In refraction, we learned that changing of medium result in change or result in diverging of ray or ray light. In reflection, we learned reflective index. The formula is sin I over sin R. We also learned total internal reflection. Total internal reflection. In total internal reflection, we learned critical angle, which we learned that if the angle of incident is greater than critical angle, then total internal reflection occurs. And critical angle is when the angle of deflection to the normal is 90 degree. And we also learned that what is the use of total internal reflection. The basic use we learned is optic fiber. These were the topics we discussed today. So this is the end of my lecture. I hope that you like my video. Give good comments to my video and subscribe my channel. Allah Hafiz. We will meet in next interesting video, inshallah.